Hi, I am Indinesh Reddy from BITS Pilani, Hyderabad campus. I am working on my project, a low-cost mini weather station. Before moving on with the project, I would like to thank my professors V. Chetan Kumar, Sai Fanindra, Avinash, Murthy Muthukrishnan and M. A. Srinivas for helping me through the project. I would also thank Texas Instrument for encouraging my project. Moving on with the project.
Need for a mini weather station. Although there is a huge advancement in the technology available today, people still rely on mass communication for weather reports. So we came up with this idea of a mini weather station which is compact and can be operated by a layman. This project will change the common man's perspective of a weather station. My main point is accessibility of the weather data at any point of time by an individual in a particular area. This is done by adding different aspects to the mini weather station like SMS integration and web access. Who is it useful for? Farmers can access the weather data just by sending a message to the weather station, and on the basis of the information received, he can make his plan of action. Similarly, a fisherman going to the sea can predict the weather situation by just sending a message to the closest weather station and find out the weather situation in the sea. As the number of weather stations in a particular area is more, we can accurately predict the weather changes. Parts used and sensor integration. The most important part of a weather station is its sensor integration. This breadboard contains all the sensors which we integrated. This is the MPX4100 pressure sensor to measure the atmospheric pressure. This is the HIH36100 humidity sensor used to measure the relative humidity of air. We used a circular potentiometer to measure the direction of the wind. This is Texas Instruments Max 232 IC which helps in UART communication. We used an inbuilt temperature sensor to measure the temperature. The output of the sensors is given to the Texas Instruments Stellaris board through 20-volt analog pins. The data received is processed by the LM4F232 microcontroller and the data is displayed on the OLED screen given in the Stellaris LM4F232 evaluation board. The received data is sent to the SMS modem or the computer using the RX-TX pins on the board. This data is amplified using the MAX 232 IC and sent to the SMS modem. The modem replies to the incoming message with the weather data. Now, moving on with the SMS integration. When we send a message reading weather to the GSM modem, it replies the details of the weather at the weather station. As you can see here, we get details of the weather at the weather station through a SMS. Coming to the graphical user interface, as you can see, this is for wind direction. This is the main menu. This is for the pressure value. This is for the humidity values. This is for the internal and external temperature display. We can also use the UART communication for communicating with the computer and storing the data in the computer or as a database. As you can see in this computer, the data is being displayed on the hyperterminal.